Hey guys, thanks for joining me again for this second video. I really appreciate you guys watching these. It means a lot. So let's today learn the second part of the Dirac notation. So last time we discussed the first part of the Dirac notation, which was the ket vectors. Now, if you remember, the ket describes some state A. For example, if we have a bit that can either be in the state 0 or 1, ket A, if that system is in the state 0, will be equal to the column vector 1, 0. And if the system is in the state 1 in that bit, the ket vector will be in the state, or the ket vector will be 0, 1 in that form. So kets are always column vectors that represent a state of a system, and that system can be any sort of things. Just in this case, it's a bit that can either be 0 or 1. If you have a dice that has 6 elements to the vector, and let's say it landed on 4, it would be the 4th element down of that vector. Now, the other part of Dirac notation is the bra. If you put them together, it's bracket, like a bracket. Not really sure why it's called that way, but it's kind of the opposite of a ket. So instead of that, it's this. And that represents a row vector. So instead of column vector, it's a row vector. And now it describes something, it's the exact same thing. It's just in a row vector form instead. In my opinion, it simplifies linear algebra and makes it a lot more easy to digest. So this vector would still represent a system in the state 0 if we're talking about bits, because it's this is the first state, possible state it could be in, and it's not in the second possible state, which is 1. So that's how we describe the bra. And in the next video, I'll talk about how we can relate these two and how they work together to tell us different things.